All right, today we're diving into something that's, well, a huge leap forward for AI. We're talking about moving beyond those simple, one-shot answers to systems that can actually reason, rethink, and even change their minds. So let's get into how it's actually done.
Okay, so if you've ever built or even just used a RAG system that's retrieval augmented generation, you've probably felt this exact frustration, right? You feed it all your documents, you ask a perfectly good question, and the answer you get back just makes you scratch your head and think, wait, is this thing just guessing?
Trust me, you are not alone. These are the exact questions that keep developers up at night. Is this a hallucination? Is it completely ignoring my documents and just using its old training data? And the big one, what happens when the information I need just isn't there? Trying to patch this stuff with code, oh man, it turns into a tangled mess really, really fast.
So, here's what we're going to cover in this explainer. We'll start with the limits of standard RAG, then dive into a new way of thinking with LangGraph. We'll look at the core building blocks, see an agent that actually self-corrects, and then wrap up with why this changes everything.
All right, first things first, let's really understand the problem. Think of standard RAG as a one-way street. Once the process starts, that's it. There's no turning back, no U-turns. And that, well, it leads to some pretty frustrating dead ends.
And this slide really gets to the heart of it. It's two totally different ways of thinking. On the one hand, you have your standard RAG pipeline. It's linear, like an assembly line. Every single step has to be perfect, because if one part messes up, the whole thing just breaks. But LangGraph, that's completely different. It's a cyclical graph. Think of it more like a workshop, where the agent can loop back, revisit a step, and actually fix its own mistakes as it goes.
And that right there brings us to the solution: thinking in cycles. This is the revolutionary idea at the core of LangGraph.
You see, LangGraph isn't just another tool in the toolbox. It's a completely new way to structure your AI workflows. By adding cycles, you give the agent the power to stop, think, and try a different path if the first one doesn't work out. This is the absolute foundation for real, genuine self-correction.
So, how does this whole thing actually work under the hood? Let's break down the core building blocks that make these smart, intelligent cycles even possible.
Okay, first up is the node. And the easiest way to think of a node is just as a worker in the system. That's it. It's just a function that does one specific job, like calling an LLM, searching a database, or generating some text.
Right, so if the nodes are your workers, then you need a way to connect them. That's the edge. Edges are just the paths between the workers. They define the flow and tell the system which node to run next. Simple as that.
So how do all these workers collaborate without stepping on each other's toes? Well, they use something called the state. And honestly, the best analogy is a shared project file, or maybe like a central whiteboard. Every single node can read from it and add new information to it. It's a single source of truth that just keeps getting updated as the task moves forward.
And this is where the real magic happens. It's called the conditional edge. Now, this isn't just a simple path from A to B. Oh no. It's a decision maker. It actually looks at that shared project file, the state, and based on what's in there, it decides where to go next. This is the if-then logic that makes the loops, the self-correction, all of it possible.
Okay, let's actually watch how this state object evolves in real time. So at the very beginning, the state is super simple. It just has one thing in it, the user's question. As you can see, the context and answer fields, they're empty, they're null, just waiting to be filled in.
Okay, now the first node, our retriever worker, gets to work. It searches the documents and boom, it writes what it finds back to the state. You can see that context field is now filled with that retrieved text. The state has just gotten richer. It's carrying the history of that first action.
And finally, a generation node grabs that new context, creates an answer, and updates the state one more time. And that's really it. This is exactly how the state object acts as this living memory, passing the baton of progress from one step to the very next.
All right, theory is great, but let's see this thing in the wild. Let's walk through a real-world example and watch how all these pieces come together to build an agent that can actually fix its own mistakes. So, here's our smarter workflow. It starts off looking a lot like a standard RAG process. Retrieve some documents, generate an answer. But then comes the crucial step, a relevance check. This is our conditional edge in action. If the answer isn't good enough, the agent doesn't just quit. Nope, it makes a decision to rewrite the query, go search the web for new info, and then generate a final, better answer.
So here's the challenge we're going to give our agent. It's a pretty tricky question, actually, because it's a two-parter. It needs to figure out who made the AI Gauss, and it needs to find their 2023 revenue.
Okay, so the agent does its first step. It searches its local documents, and it finds part one of the answer. The company that made Gauss is Samsung Electronics. But, and this is key, it also correctly identifies that the revenue number is missing. Now, your standard RAG system, it would just stop right here and give you that incomplete answer. End of story.
But this is where LangGraph just completely shines. That relevance check node looks at the incomplete answer and flags it as not grounded. It basically raises its hand and says, hey, I don't have enough info. It recognizes its own failure. That flag gets written to the state, which triggers our conditional edge. The system now knows it needs to try something else.
So, what's the next move? This is the cool part. It doesn't just blindly throw the original complex question at a web search. No, it intelligently rewrites the query to be way more specific. It focuses only on the missing piece of the puzzle. What is Samsung Electronics' 2023 revenue? I mean, that is a massive leap in reasoning.
And of course, with that super targeted query, the web search is a success. It finds the exact number. This new piece of information gets added to the state. And now the agent has everything it needs to give us that final, complete answer.
Okay, let's just zoom out for a second here, because what we just walked through, that is not just a small improvement. This is a fundamental shift in how we build these things. We're moving from simple, dumb pipelines to creating truly intelligent agents.
So, the big takeaway here is this. With LangGraph, you're not just building systems that follow a script. You're building agents that can reason, they can choose their own tools, they can evaluate their own work, they can rewrite questions on the fly, they can tap into new sources of knowledge, and all of this leads to AI systems that are just so much more robust, reliable, and transparent. This is how we finally get past the frustrating limits of basic RAG.
And that really leaves us with one final thought to chew on. For so long, we've designed AI to just follow a fixed path, a straight line. But what becomes possible when we build systems that can actually pause, reflect, and decide to take a different route? So I'll leave you with this. What kind of problems could you solve if your AI could genuinely change its mind?